Hey guys, I wanted to do a video today about trigonometric substitution. It can be a little hairy, so I thought I might show you guys how it's done to maybe help you out a little bit. So let's see. Trigonometric substitution is all about, our goal is to sub to theta. We want to sub into theta and then reduce to a trig integral. Okay, so we want to sub everything into theta, reduce it to a trig integral, do our integration, and then back sub. Back sub. Okay. So that's the goal of our trigonometric substitution process. What it's for is for dealing with certain structures of integrals. So integrals that involve root a squared plus u squared, where a is a constant, and u is a continuous function, some f of x or f of y or whatever. Okay, so this is one of the structures that trigonometric substitution is used for, sum of two squares. Also, a squared minus u squared, the difference of two squares, where your function comes second, and the reverse u squared minus a squared, where your function comes first. Okay, so these are the three types of structures that trigonometric substitution is primarily used for. Now, we've already been confronted with structures like this when we were looking at arc length and surface area, right? And those questions that we looked at before, they were very, very cherry-picked. We had to jump through some major algebraic hoops to get outside of that root or to be able to do a u sub. A lot of the times that's not going to work. And so this is more a general tool for dealing with those types of things. All right, so that's what trig substitution is for integrating these types of structures. And our goal is to sub into theta, reduce it to a trig integral, do our integration, and then back sub. All right. So let's see, the first pattern we'll look at is, let's look at root a squared minus u squared. Okay, a squared minus u squared, so a is our constant and u is a continuous function. If I have this structure, then the substitution that I want to use is u equal a sine theta. Okay, so that's the substitution that I'm going to use. And I determine that just based on this structure, that it's the difference and the continuous function comes second. So let's try an example. Let's try integral 4 over x squared root 16 minus x squared dx. Okay, so I've got to, you hand me this problem. First thing I'm going to try to do is go into this composite in the denominator and u sub. Ideally, I'd really like to turn this into a power rule and make life easy. But my du is only going to give me 2x, and I've got x squared out here. So u sub, not really going to work this time. I'm pretty much stuck with that root down here. Okay? So since my function comes second, I'm going to look at this and I'm going to say, well, this is 4 squared. That means that a has got to be 4. And this is x squared, so u is just x. That gives me my substitution here. U, which is x, is equal to a, which is 4, sine of theta. So x is 4 sine theta. Okay, now my goal, like I've said, is to sub everything in here into theta. So I've got to worry about everything that's here. I got to get rid of it everything that's in terms of x. So this 4, I can really pull it outside. It's just a constant. It's not going to do anything. But let's see what we get from here first. First of all, I've got what x is. So this x squared, no problem. What's x squared? Well, it's just square of this, 16 sine squared theta. Okay, so I know what this x squared is now. I need to know what dx is. Well, from here I can get it. Let's see. Dx is 4, derivative of sine is cosine theta. D theta. Okay. So now I know what this x squared is in terms of theta. I know what dx is in terms of theta. The only thing that's left that I need to worry about is this root business. Okay. Now, in order to get this root business, I'm going to construct a reference triangle. And it's going to be really, really useful for our last step, back subbing, once we've done all the integration as well. So we usually want to draw it somewhere off to the side where we can hang on to it until the end of the problem. And how I'm going to construct that is directly from this sub again. Not only did this give me x squared and dx, but this tells me what the sine of theta is. The sine of theta is x over 4. Right? So that means that sine is opposite over hypotenuse. So the opposite must be x, and the hypotenuse has to be 4. So let's start to build our triangle here. Got a right triangle. There's my theta. I know that the opposite is x, and the hypotenuse is 4, which means that this side has to be the square root of 16 minus x squared by the Pythagorean theorem. All right, now what I'm after is that root. I want to define that root in terms of theta. And I don't want to reintroduce another x variable. So I don't want to use, say, the tangent of that. I'll instead use, let's see, adjacent and hypotenuse, that's the cosine. So I say the cosine of theta is the adjacent, the root 16 minus x squared, over the hypotenuse, which is 4. Just by definition of what the cosine is here. And this allows me to solve for the root business that I was after. That is to say that the square root of 16 minus x squared is equal to 4 cosine of theta. Now I've got everything that I needed. I needed x squared, I've got that. I needed the root, I've got that. And I needed dx. So I've got that in terms of theta. Now I have the ability to sub everything in. So let's see, we've got 4 over. The x squared is 16 sine squared theta. 16 sine squared theta. Let's see, the root was 4 cosine theta. And dx is 4 cosine theta d theta. Okay, so I've subbed everything in my original problem to thetas. Now, let's see, I should be on a good road here. Let's see, the 4 over 4 become 1. I've got a 4 over 4, that's a quarter I can pull outside. Takes care of the constants. Cosine over cosine, that becomes 1. And so I have 1 over the sine squared of theta, d theta. Sine square, 1 over the sine square, that is cosecant squared. Cosecant squared theta, d theta. Cosecant squared is one of our basic quote unquote rules. It's one of the more complicated ones, but it's one of the ones we should have in our toolbox here. So if I remember correctly, cosecant is negative ln absolute value cosecant cosecant theta plus cotangent of theta. Okay. Now we've done our integration. We subbed everything in. We reduced it to a trig integral. We've done our integration, and now we need to back sub. Okay? Let's see. Everything, our answer here is all in terms of theta, but we were asked to do our original integration in terms of dx. So we need to somehow get back here. Now let's see. Cosecant of theta is 1 over the sine of theta. Do we know what the sine of theta is? Sure. So it's just a reciprocal. Cosecant is 4 over x, negative 1/4. And the cotangent, let's see, the cotangent is a reciprocal of the tangent. The tangent would be opposite over adjacent, so x over the root. Flip those over. I've got the root 16 minus x squared over x plus c. And we're done. Okay, so that's the process for trigonometric substitution. And again, I'm using my reference triangle. When I get to here, I'm trying to figure out what is the cosecant of theta. Well, it's the reciprocal of the sine. What's the sine of theta? I had it here already solved, but I could have got it from here as well. And likewise, I did the same thing for the cotangent. It's the reciprocal of the tangent, so I just look at my triangle. What is the tangent of theta? Opposite over adjacent. Okay, so flip it over. Okay. So that's when the pattern is difference of two squares, where the function comes second. Let's try one where we have the sum of two squares. How about integral of x cubed over 4 root 4 plus x squared dx? Okay, I look at this and I go, okay, can I u sub? Well, my du is going to be 2x. I've got x cubed. That's too much. So that's not going to work, unfortunately. So I'm stuck with this root down here. I'm looking at the structure. It's the sum of two squares. That means I'm going to use, I want to use the substitution u equal a tangent of theta. I got the sum of two squares. Here, this is 2 squared, so a is 2. And this is just x squared, so u is x. Gives me the substitution. X is equal to 2 tangent of theta. All right, let's see. What all stuff do I need? I need x cubed. I can get that from here. X cubed is 8 tangent cube of theta. The 4 doesn't bother me. I can just pull that outside if I don't want it later on. Let's see. I need the root. We'll get that in a minute. I think I can get dx from here. Dx will be 2 derivative tangent of secant squared theta and theta. All right. That means I'm going to build my triangle. There's my theta. And let's see, I have that the tangent of theta is x over 2 from my substitution right here. So that means that we've got the opposite is x, and the hypotenuse is 2. Adjacent is 2, tangent, opposite over adjacent. Which means that the third side has to be the square root of 4 plus x squared by the Pythagorean theorem. All right, I'm on the track of trying to get the root. Again, I don't want to reintroduce another x, so I'm going to use the adjacent side. Adjacent and hypotenuse, that is cosine again. The cosine of theta is 2 over the root 4 plus x squared. But I want to solve for the root, so I'm going to take the reciprocal here. And I've got root 4 plus x squared over 2 is 1 over the cosine is the secant of theta. And that gives me that the root 4 plus x squared is 2 secant theta. All right, so let's double check. Don't worry about the 4x cubed I've got here. Dx I've got here. And the root I have here. So everything in here I should be able to sub now for thetas. All right, x cubed is 8 tangent cube of theta. There's a 4 downstairs. Our root is 2 secant of theta. And dx is 2 secant squared theta. D theta. All right. So let's take a look at what we've got here. This 2, 8 over 4 is 2 times 2. This 4 I can pull outside. One of those will go. I've got tangent cube theta secant of theta d theta. I'm going to try to hold off one of the tangents and convert the other 2 to secants, because I think I want to, this is one of those funky ones that I actually want to u sub for secant. So let's try that. Again, if I u sub for secant, the du is going to be secant tangent. That's why I'm holding one of those. Secant theta, tangent theta, d theta. I'm holding that off, which gives me a tangent squared theta here, which I want to convert. So 4 integral, okay, we got to remember, I think it's secant squared minus 1. I always have to rederive those. Let's see, cosine squared plus sine squared equals 1. I'm looking for the tangent one, so I want to divide by sine. Tan squared plus 1 is equal to the secant squared. So tan squared is secant squared minus 1. Ran out of space. D theta, that's a d theta, sorry, it's squished. Okay. All right, so here I've got 4 integral secant squared theta, secant theta, tan theta, d theta. I didn't combine these together because I'm holding that off. I want a u sub right here. This is going to be an easy power rule as long as I've got my du there, secant tangent. And then over here I have minus 4 integral secant tangent, so secant theta, tan theta, d theta. Now we know that secant theta, tan theta is the derivative of secant. So that's an easy integral. That's just 4 secant theta. You can do that right away. Over here, I'm going to u sub. So I've got 4 integral u squared du, where u is the secant of theta. Du is secant theta, tan theta, d theta. All right. So this is going to be a straight power rule. I have 4/3. U is secant theta, so secant cube of theta. minus 4 secant of theta plus c. Well, usually I just don't bother with the plus c yet because we still have one more step. We got to come back to our reference triangle because the original was in terms of x, so we want to make sure that our answer is back in terms of x, not in terms of theta. And I just erased my sub. No, did we already have the secant of theta? We do have, we've already solved for the secant of theta. So we already have it right here, we just need to back sub it in. So 4/3, we have, it's secant cubed, so this would be over 8. So this would be over 24, 4 over 24, 2 over 12, 1 over 6. And then we have 4 plus x squared to the 3/2 power. So I've just cubed that up, right? Did I do my end? Did I do this right? Did I forget my 4/3? No, I think I did, right? And then minus 4, we've just got the straight secant theta, so 4 over 2, that'll be a 2, minus 2, root, well, let's be consistent with our rational powers, 4 plus x squared to the 1/2 plus c. And now we're done. We've done our back sub, we've got it back in terms of x, and we didn't forget our plus c. That's it. Okay, so that was one where we had the sum of two squares. So our substitution is u equal a tangent of theta. Our third kind, they're very, very similar in structure. It's just the difference is what sub we'll use. So if our function comes first, then we'll use u equal a secant theta. So let's try 1 over root x squared minus 25 dx. Now if those had been reversed, 25 minus x squared, then I would have gone u equal a sine theta. But since my function comes first, I'm going to go u equal a secant theta. All right, in this case, u is just x, because we just have x squared, and we've got a is equal to 5. That's 5 squared there. So u is equal to a secant theta. All right, can get dx from that. I mean, we don't have any other x cubes or anything we need to worry about. So dx we can get right away. Let's see, 5 secant theta tan theta d theta. And now the only thing that's left is the root itself. So let's build our triangle. There's theta. And I've got that the secant of theta is x over 5. Now, I always find it relatively difficult to think about what the secant is, so I usually convert it. This is what, 1 over the cosine, so that means that the cosine of theta is 5 over x. And that's usually easier to understand for me, at least, because that's opposite and that's hypotenuse. Or adjacent, excuse me. That's adjacent and that's hypotenuse. So adjacent and hypotenuse by definition of the cosine, which means that this third side is the square root of x squared minus 25 by the Pythagorean theorem. Again, I'm trying to get at that root so I can sub it in, and I don't want to reintroduce this, so I'm not going to use the sine, opposite over hypotenuse. I'll use the opposite over the adjacent, that's the tangent. So the tangent of theta is the opposite, it's x squared minus 25, over the adjacent, which is 5, which means that my root, x squared minus 25, is 5 tan theta. Nice, so I know what the root is, I know what dx is, that should be everything that I need to be able to sub in. integral 1 over, this root is 5 tangent of theta, dx is 5 secant theta tangent of theta d theta. And that's everything. We've got our root, we've got our dx. Let's see, 5 over 5 simplifies, that's just 1. Tangent over tangent, that's just 1. So we've got integral of secant of theta d theta. Nice, that's one of our quote-unquote basic rules, right? This is ln, absolute value, secant of theta plus tangent of theta. Now there's a plus c on there, but I still have one step, right? I still need to back sub. Now I already know what the secant of theta is. I don't need to figure that out. I've already solved for it. So I have ln, absolute value, the secant of theta is x over 5 plus the tangent of theta. Do we have that already? Ah, we do. It's the square root of x squared plus 25 over 5 plus c. Bam. And we're done. All right, so those are the 3 patterns for trigonometric substitution. Let's do one more, because we've only seen ones where our u is something simple. Another thing to note, too, is if it's not 2 perfect squares, that's easy enough to get around. Just as a quick aside here, like if I have the square root of x squared plus 3, I'd say, oh man, I'd really like to use u equal a tan theta on that, but 3 is not a square, right? So, okay, well, this is not the sum of 2 squares, so I can't use it. Well, yes, you can. Square root of 3 squared. Now our a is root 3. We have the sum of 2 squares, and off we run with u equal a tan theta. Okay, so that's a little bit of an algebraic trick there. If the constant is not a perfect square, you can just make it the square of the square root and be done with it. Okay, let's look at one more example where our u is something slightly more complicated. Let's say integral of 1 over x root 9x squared plus 1 dx. Okay, first instinct is to u sub, right? I'd get 18x as my du. Unfortunately, so close, but no cigar, right? You can't just sub in here. This is actually 1 over x. So I don't have it. If that x had been upstairs, it would have been a u sub and we would have been done. But the x is downstairs, so I'm stuck with it. It means I'm stuck with that root. I can't u sub it away, turn this into a power rule. So I'm off and running on u equal a tan theta. This is the sum of 2 squares. But here, this is 3x squared, which means that my u is going to be 3x this time. And of course, a is 1. 1 squared is 1. Okay, no problem. So u equal a tan theta, 3x is equal to 1 times the tangent of theta. Now really you can do it over 1 if you want to think about the fact that it's opposite over adjacent, so that we know how to lay out our reference triangle there. All right, so I need x. X is 1/3 the tangent of theta. I'm just solving that. So we've got our x. We need dx. The derivative is 1/3 secant squared theta d theta. So we know what x is. We know what dx is. Now we need the root. There's my theta. Let's see. the tangent of theta, the opposite is 3x. The adjacent is 1, which means this side has got to be the square root of 9x squared plus 1 by the Pythagorean theorem. Now I'm going to use the adjacent and the hypotenuse. Adjacent and hypotenuse tells me that the cosine of theta is 1 over square root of 9x squared plus 1. But I want the reciprocal, right? I'm trying to solve for this root. So the square root of 9x squared plus 1 is the reciprocal of cosine, which is the secant of theta. All right, so now I know what the root is, I know what x is, I know what dx is, I should be able to sub everything in. 1 over x is 1/3 the tangent of theta. The root is just straight secant theta. And dx is 1/3 secant squared theta, d theta. All right, well, 1/3 over 1/3, those become 1. Let's see, I've got a secant upstairs, secant theta, and a tangent downstairs, tangent theta, d theta. All right, now I don't have anything that I don't have any squares. I can't use the Pythagorean identities or anything. So I'm sort of stuck. If I had a secant squared here, I'd be done because I could u sub for tan and I'd have du, but I don't have enough there. So the only thing that I can really do if I get stuck at that point is try to figure out what they all mean by definition and see if life gets easier. So let's see, we've got the secant, which is 1 over the cosine of theta, and the tangent, which is the sine of theta over the cosine of theta, d theta. Dividing by a fraction is multiplying by the reciprocal. We're going to get 1 over the cosine times the cosine over the sine. Cosines become 1. I've got 1 over the sine. Reciprocal of the sine is the cosecant. Nice. So that's one of our basic rules. We saw that one earlier. Integral of the cosecant is negative ln absolute value of cosecant theta plus cotangent of theta. All right, so we've done our integration. We just need to back sub. Can't leave it as thetas. So let's see, the cosecant, well, we know what the secant is. Well, no, wait, let's see. Do we know what the cosecant is already? I don't think so. Nope, so let's see. Cosecant is 1 over the sine. The sine is, sine of theta is opposite 3x over the root 9x squared plus 1, opposite over hypotenuse, and the cosecant is the reciprocal of that. Cosecant theta, cosecant theta is the root 9x squared plus 1 over 3x. So we got that bit. The cotangent is the reciprocal of the tangent. Tangent is opposite over adjacent. So it looks like 3x over 1, so take its reciprocal, plus 1. Oops, I shouldn't do it there. The cotangent of theta is 1 over 3x. So we have their sum, we already have a common denominator. Negative ln absolute value square root 9x squared plus 1 over 3x plus c. And we're done. I just added those together over common denominator. Yeah. Cool. All right. So that's trigonometric substitution. I hope you guys get a chance to play around with that a little bit. And if you have any questions, shoot them over on Discord and I'll help you out.